But hey, everyone, thanks for joining in. Thank you for taking the time. For those of you joining in for the first time, my name is Prof. I'm a researcher at LostFunk, which is an independent lab based out of Bangalore, India, where our goal is to explore general intelligence in all its forms, including biological and artificial. This is the first of 4 panel discussions that we're hosting as a part of Conference for AI Scientists, which is an initiative that LostFunk is organizing with BITS, which is one of India's largest and most premier STEM universities. The premise of the conference has been we invited folks to submit papers that were partly or almost entirely authored by AI systems. And the goal was really to probe the limits of these systems, as well as draw more and more attention to the changing paradigm of doing science with the aid of AI. We finished the conference, we had over 200 submissions, 30% of them were global. We had an acceptance rate of about 40%, and it's been wonderful to see what all folks have attempted with AI systems. So that's been great. And like I said, this discussion is a part of our second goal, which is to draw attention to how the paradigm of doing science is changing. Super excited for this session. Quick introduction to the speakers who are joining us. We have Professor Chenhao Tan. He's an associate professor in the Faculty of Computer Science at University of Chicago. He's the director at Chicago Human+AI Lab, and he's also the co-founder of SAI. We have Dr. Federico Bianchi, who's a staff ML scientist at Together AI, has previously done postdoctoral research at Stanford, and he was actually one of the organizing committee members at Agents for Science, which was the conference that inspired us to do the work that we're doing at Conference for AI Scientists. So it's glad to have him here. Particularly excited about the speaker panel, like the two of them, because in the last couple of years, they've worked across the gamut of LLMs for science, starting with hypothesis generation to experiment execution, multi-agent collaboration, focusing on verifiable problems, exploring what AI peer review looks like. And more recently, I think Professor Tan did a bunch of work on reproducing research work as well. So and that's sort of why the session is called AI Across the Scientific Method, because the two speakers have sort of worked on how AI comes in at each stage. And last but not the least, we're very grateful to have the conversation moderated by Dr. John Bohannon. He's done his PhD in molecular biology from Oxford. He's done postdoctoral research at places like Harvard and Berkeley Institute of Data Sciences. He's currently a self-founder in robotics, and he's highly regarded for his work in science journalism as well as investigative journalism. I was just going through some of the columns that you wrote for Science back in the day, and I think it was wonderful. He's very well known for his column, The Gonzo Scientist, and one of the breakthrough pieces that he did was Who's Afraid of Peer Review back in the day, where he intentionally submitted a false paper to a bunch of journals to showcase the predatory publishing practices of those journals. So very excited to have John moderate this discussion, as he's seen sort of science evolve, and he's been at the edge of questioning the nature of science as it's done currently, right? And with that, over to you, John. I'll let you all have a great discussion. Thank you again for taking the time.
True, thank you. Good morning and good evening, everyone. Let's dive right in. This topic is kind of, if you had told me we would have such a conversation even 2 years ago, I would have been like, yeah, okay, yeah, I know what AI can do. At the time I was part of the crew building AI, and you had language models and they were getting large, but like pretty useless stuff, honestly, when it comes to science. The human scientist was still in charge. There was just nothing touching that kind of human work. Things have changed. So as I talk to you right now, on my other screen, I'm watching my Claude agents run several experiments. They designed the experiments. They're running the experiments. Do they mess up? Hell yes, all the time. But I can't go back. It's just too productive. If I designed and ran all of these experiments myself, I would be working at 1/10 the pace. So we are in a new reality. So what this discussion is going to be about is not the hype. So what I'm going to do, dear audience, is keep us grounded in like what actually works today, what the problems that we see today are, and then we'll talk a little bit about the future, and we'll allow ourselves a little bit of fun hype. But let's keep it grounded. So we've got Fede and Chenhao here, two deep experts in the topic. So gentlemen, help us set the stage for what today's reality is like. Let's start with Fede, just because you're on the top left of my screen, and give us a sense of like, what is it good at across the tasks of a human scientist, And where does it fail? Let's be realistic.
Yeah,
Today.
that's a very good question. So first of all, my feeling is the same as yours. That is like we went from language models that couldn't do interesting stuff to language models that can do a lot of stuff very quickly, like incredibly quickly. So my work has completely changed in the last 2 years. I also have an agent running right now, doing things for me while I'm here. So my feeling is that like the agents are very good at most of the scientific pipeline, but they are 80% there. So they're very good at like doing search and doing literature search, but they're not perfect. They're very good at like coming up with experiments and doing experiments, but they're not perfect. They're very good at maybe the thing they are not as good as humans is writing. Writing is still an open problem for language model, at least like coherent writing is a problem. So like we are there. We're very close to have automated pipelines, but we're not there yet. There are hallucination problems with literature search. There are like coding bugs or like agents not following instruction and assuming they implemented something that is not true. But it's very useful. Like it's very productive. Like, and as you said, we can always go back and check and look at actually if things are correct. So yeah. Very good at doing most of the pipeline, not the entire thing. That is my.
So the human is still in charge.
Yes.
But could you go back? Could you stop using agents to do your scientific work?
No, absolutely not. I don't.
There's no going back.
I don't think I could go back. I think like this is like too productive in the general sense. I can run many things together. I can run 4 projects together.
But you're paying a tax, Fede.
I pay the context which tax.
No, you're paying a tax. You know that you do 4 experiments, one of them is going to fail.
Yeah, sure.
And you're going to spend a bunch of time discovering it and fixing that stuff. That's still worth it. It still pays off.
It's the scale. Like I can search at a higher level of scale, and then I'm gonna check things. But yeah, definitely.
Okay, Chenhao, any change in that view?
No, I think I agree with most of the things that people have said. I think I maybe like I'll push back a little bit on like it's easy to check the AI outputs. I think it's kind of like hard to actually know where things went wrong sometimes, and I think like also I'll be admitted that I might be like among the 3 of us. I don't have an agent writing experiments right now. I think I'm like my students are still be the agents, are still the kind of main agents that are running the agents to run experiments in a way, and like I'm caught up in this reviewing service right now. I don't think I'm passing any of that to agents right now. But like as Drew mentioned earlier, I do think like for instance like checking things can be a good job for AI to do as well if we have the right structure. And we recently had an experiment on replicating like as much as we can ICML oral papers. And like one thing that we did learn from that exercise that is actually very expensive. I do think like I had a blog last year on this already. Like I do think AI will play a bigger role, but I think it's also useful to realize like a lot of things in science is a resource allocation problem, and like running experiments is not free. Your attention is not free, and I don't think like launching too many experiments is the optimal solution for most scientists. But at the same time, as like I think Joe has mentioned, like I think I'm also doing a startup myself, so I think I'm talking to more and more scientists outside computer science. I think this view that we are talking about right now is also not really widely shared by a lot of different scientists in other disciplines. I think AI has a lot of potential in helping them in their scientific workflows or in many different aspects, but I think they are not adopting AI in the way. Partly, I do think like they are also seeing a lot of concerns about hallucination or like, and even just about the very nature of like what science is. Maybe like that's something we can talk more in the second part of this discussion, where I think that part will also change. Like I think John was alluding to that when you were talking with Fid. I do think humans will be in charge of like part of the process, but like humans may not be in charge of science in the future in many ways.
Fede mentioned that search is something that AI is really good at. So if you're doing a literature search, if you're looking for patterns in, big gross collections of files and data, it's really good at doing that kind of slow and steady work. And I think part of that is summarization. When you're good at search, you also get really good at summarization. What's something else, Chenhao, that you feel like the tool is exceptionally good for the life of a scientist?
Yeah, I think like another very, like maybe this is related to search, but I do think it's very rare that you have an expert in such a wide variety of disciplines. Like, I think connecting the dots, like I guess like sometimes there are discussions about like, I think there are two parts of this, right? I think like one, I do think AI's research taste is still far from good, at least in my opinion. And I think like its ability to come up with like good new questions is still very limited.
When you say taste, you mean looking at something and saying that's an experiment worth doing, or that's a result worth looking deeper at?
I think pretty much across every stage, like starting from the beginning, like whether research question is worth pursuing, whether like experiment, like I think AI is very good at designing reasonable, plausible experiments. But you like, I think there are many different, also like I guess the backstory is there are many different types of science, right? Like I think any funding, as long as it's a valid funding, I think it can contribute to the knowledge base to some extent, but it may not actually shift science in any fundamental ways. And I think when most people talking about taste, I think is about the latter type, where like you are thinking about questions that are fundamentally going to kind of change science in some way. I think AI is still not good at doing that job. But at the same time, I think AI is very good at connecting the dots. That, like, for instance, like I don't know, like I think often cases like many material, like I think this is just an example from other colleagues. Like in material science, I think they all know certain finding in chemistry can be very useful for their research, but it's just important to actually consume that set of research, right? Like, and I think like that kind of connecting the dots doesn't require AI to actually do anything for groundbreaking. It's just like knowing something's there, I think is already very helpful. And I think like these kind of distinctions can be useful, and in thinking about like how AI can be used in this kind of in helping research.
So it sounds like what you both are saying is there's two roles for AI in the life of a scientist today that are solid. One is basically what we use Google for back in the day, and less so. Now we just use, AI as the intermediary between us and the world's knowledge. So it's like a book that talks, extremely helpful. It has access to all human knowledge with, varying degrees of coverage. And that's just useful, period.
Yep.
There's another side, which I didn't hear you guys talk about, which to me, I'm doing robotics and I have to write a lot of code and do a lot of RL experiments. For me, the thing that's most transformative is having a software engineer, like not just a knowledge bank, someone who can build things for me and help me iterate fast. I'm able to run experiments. Just over the past 3 months, I've run more experiments than my entire life. That's just crazy. That's just mind-blowing. That kind of exponential curve. Like, I don't think everyone has woken up to this. Like you said, Chenhao, or was it Fede? Outside of computer science, in the other parts of science, they're still asleep. It hasn't woken them up yet, because their day-to-day problem solving hasn't been so transformed. But in computer science, my God, who writes code anymore?
I don't.
Can you imagine a change so dramatic in a huge, highly paid piece of human labor, where almost overnight you stopped doing the fundamental thing and you just have a machine doing it? This is like the agricultural revolution sped up 1,000 times. So, that's crazy. And I'm surprised you guys didn't mention that first. It feels like such a transformative thing.
I think, like, I don't know. I think Fede kind of mentioned that earlier. I think, I don't know, like running experiments, writing experiments, designing experiments, running experiments. I think what powers that is writing code. That is like, especially in our day-to-day work. And but I totally agree. I think like this capability of like being able to actually write code and run code, or like I think this is also more than writing code, right? Just using tools is very important. And I think that is like certainly a strong
it sounds like when you think of science, you're really thinking about prestige science. You're hunting for breakthroughs. Everything else is details. And so like writing code just means you're writing more bad experiments. What matters is the right experiment, and hence scientific taste is what matters. Me, I'm a brutalist. If you brute force, if you hire 10 times more scientists than you have, yeah, of course the quality level is not going to increase, but man, you're going to cover more ground.
Yeah, totally. I think just to be clear, I meant that those are two perspectives I think that are equally valid, and I think like both are you important for the progress of science in many ways, and also I do think like going back to the resource question, right? I think like just running 100 experiments is not necessarily like free, and even if just for computer costs, right? Like you are like I think in the optimal world, you still want to run the right 100 experiments if you can. Right. But I do think I totally agree with you. Like we are kind of in this phase where agriculture revolution sped up 1,000 times. So like we could run a lot of experiments. It's a capability that we never had. Yeah. So like we are trying to figure out how to use it. I think this like also applies to, I don't know, personally, I do think like publishing is like really at a mess right now, especially in computer science, right? Like, and I think there's a lot of what motivates like this recent replicating exercise. And I don't think that exercise itself is perfect, but I think a lot of this like in the process of thinking about what the future could look like. And I think it will look very different. Agriculture is different now from 1,000 years ago. And I think this timeline will be much more.
The biggest impact is we can support a population of 8 billion humans on this planet. What is the AI equivalent of that?
Yes.
Like, I can't even imagine. What is the AI equivalent of suddenly 1000xing the knowledge output of the planet? I have no idea.
I mean, going back to like the expensiveness point, humans are also expensive, right? So those are like this kind of point that like the scale that AI has access to in terms of experiment allow us to run things that like we cannot spend human time on, which I think it's very important. Like there are some problems that now are getting solved just because like someone has asked a question to ChatGPT that like no one wanted to ask, or like no one want to spend an entire PhD on. So
because you've reduced the cost of curiosity. Curiosity used to be so expensive. You had to throw a human at it for 5 years. Now 5 weekends.
You need so much. You at least like 2 years ago you needed so much starting knowledge that right now you might not need. Like you might have like, as you said, some curiosity, and you can just ask a question to ChatGPT, and you might have like some portion of this kind of knowledge. You might know portion of the problem, not the entire thing. You can just catch ChatGPT, and ChatGPT is gonna give you like, it's gonna speed up your understanding, but it's gonna also try to solve the problem.
So let's shift gears. Let's talk about something that you're excited about, which is starting to be developed. Maybe it's not finished yet, but you think it's a strong direction as a tool or a framework, or maybe just you think the size of the model is what matters. And that's one school of thought, is all of these details. Oh, I built a better framework. Oh, It's not going to matter. All of that is going to wash under the bridge with the next big large language model. I am on the fence, by the way, personally. I do agree there's more juice to squeeze, but I think we are missing some things. As a day-to-day user of LLMs, I have good intuitions about where they fail. And as the models get smarter, they don't seem to improve on these fundamental flaws. Taste is one of them, but I think there are others. So Fede, you first. What is a direction or a piece of progress, or something that you think on the timescale of the next year could really change things?
Yeah, good question. Hard to say if this is like as a 1 year timeline, but I cannot still leave my agent workflow completely unattended. I still need to look at code sometimes. Still maybe doesn't understand things. When it fails, comes up with its own experiment that is not what I wanted. So I think like we are still going in the direction of like more autonomous agent, and I hope we get there. And once we get there, all the pipelines are going to be more agent first, and they're going to be more autonomous. And I'm pretty sure that like with the new models, faster models, better models, we are going to get there. And that's my biggest hope, because like right now, a lot of my work is like the reviewer kind of work. And so that is one. I hope models get better at writing. My biggest pet peeve with like models nowadays is like writing is not good. I feel like when I ask a model to write something about my experiment, the writing is never written in a voice that I like. And scientists have their personal voices and they like text written in a certain way, but it's very hard to prompt a model to not edge the statements in the right way, which is something that is very important in science. Like you want certain statement to have a certain kind of weight, and language models are still not very good at finding that kind of position.
Yeah, it's not just style, it's slop. It's beautiful slop, grammatically perfect slop. Whenever I have it write anything, there are whole paragraphs that are just repeating the point or just kind of like saying nothing. And that kind of hot air, I'm not sure how that goes away. Then again, if you had told me that, 5 years ago, that my major complaint would be generating entire coherent scientific papers would be too verbose, I'd be like, that sounds pretty great. Chenhao, what do you think is on the 1 year time scale really exciting?
Yeah, I think, I don't know, I'm not sure this is the 1 year scale. I hope that we can make great progress, but I do think like human AI interaction with this kind of long horizon agents, I think is a big unsolved problem, both at individual level. Like I think as Fede was mentioning, I think like now, and the agent becomes very capable. Even if the agent becomes like fully autonomous, can do this imperfectly, I think like this part of like explaining the outcome to me is still important. But I do think like for a lot of reasons that we discussed, I don't think no matter how capable the agent becomes, there still needs to have intelligent interaction between the human and the AI for the result to actually make sense. And the second part of this, like I think I was alluding to this earlier, I do think this interaction is not just at like this one-to-one level. There is this more ecosystem interaction, especially in the context of science, right? Say AI can publish 1 million papers, they are all good, they are fantastic, but I wouldn't not know them, or like I will never personally read that 1 million papers.
Who wants to read them?
Yeah, so like I don't think we figured out that, and I don't think there's a model inside of questions. Maybe like certain maybe at that scale we need a certain capabilities that we haven't really imagined about. And I think like at both of scales there are also questions. I think like in the chat, Drew was talking about alignment. Like I do think like the question that I've been thinking about a lot is this question of research sabotage. I think that like happens a lot in both of these interactions.
Tell me more about that. What do you mean?
I guess this is kind of one of the questions in the alignment context. I guess roughly it means that like maybe AI will intentionally like come up with bad ideas for you, or like intentionally just like try to sabotage your research progress in ways that are very hard for you to detect. And like this could be like running a particular experiment that like AI knows is going to fail, but it tells you that this is experiment worth running and running it, right? Like anyway, some of this, it's hard to decide whether AI is actively sabotaging or just AI is not good enough. But I think in both cases, the outcome is similar. Like as a result, like you spend a lot of time looking at AI outputs, you spend a lot of resources running experiments, but in the end, you do not get the outcome that you hope to see. And I think in research is particularly challenging, since because there's inherent uncertainty in this process, and it's very hard to judge which way it is. And I think that's a very important question. But I kind of broadly looped that into part of the interaction problem. And I think as AI becomes more and more capable, and all these interaction problems gets almost magnified into things that like we haven't really thought about, or we just don't have a good framework to think about, because we never had such powerful kind of I guess agents running around.
So, okay, now I want to shift gears again and look a little bit further ahead. What we've talked about so far is like where we are today. And as you and the audience have noticed, like the conversation really stays grounded in tools, like help me write, help me review, help me design an experiment, write some code, do some search, summarize some data. These are tools, and tools are nothing new. Science has moved forward one tool at a time, and AI is just another tool. But let's look ahead where AI, you can't really say it's a tool. It's something beyond that. Like if a PhD student is a tool, then okay, then that's what we're talking about. But I'm saying like it's more of a scientist itself. It's a complete unit of scientific investigation that is kind of like doing its thing. So let's say it's something tool plus. It's beyond a tool. I just posted a link in the chat. This is something I'm fascinated with just over the past few days. And it's both promising and I think a warning. So what I posted is something called schema. It's a very clever framework that someone made that you put a frontier model in, and it demonstrably does better at these puzzle games, such as the ArcAGI puzzle. So promising because I'm starting to see tools like this where it's a wrapper that actually, kind of covers the whole scientific arc of investigating, creating experiments, and doing things empirically. Not just we've all made some version of an agentic flow where it does n experiments, and for each experiment you do a thing, and then you summarize the results, and then rinse and repeat. And let's be honest, it barely works. No one can say, honestly, that they've made an agentic flow that does a significant piece of scientific work, or frankly, even engineering work, except for the most lowly bug hunting type work, and have it work. But stuff like this is exciting. Here's the warning, though. Like the ArcAGI test, like any test, if you beat it because you just learned how to take the test, it doesn't mean it's going to generalize. And so I think we're coming into a period where we're going to have a golden age of frameworks, which beat test after test after test and absolutely do not generalize into a scientist. There's always going to be, just this hard wall where if you waste your time just trusting this agent to do science, you'll be disappointed. It's going to fail, and it's going to be a waste of time. We're still in the era of tool. But let's look ahead 3 years. So my question to you both, Fede, Chenhao, what do you think is the likely path, if it is possible, to get to a true AI scientist? An AI scientist that you would trust with a problem, not just a puzzle. AGI, ArcAGI is an example of a puzzle, but a true scientific quest. And maybe you want to draw a line about what you would trust it to, how big that quest can be. Maybe it'll be very small quests, but the kind of quest you would give a grad student. So, 3-year time scale, what do you think is the path? Is it just bigger models, better frameworks, or is there something magic we're missing?
Yeah, that's a good question. It's probably a combination of both, and it's unclear what contribution each is going to give. Right now it's very hard to bet against scale, right? Back 6 years ago, we were discussing of scaling bird-sized models and the complexity of scaling that and how expensive that was. And now bird models are 100 times.
They're toys.
Yeah,
it's
yeah.
Easy.
The comparison is it's great. So it's very hard to bet against scale and end-to-end approaches to do these things. It's very hard also to think about how can we build end-to-end science with a single model, which is an open question. So it's definitely something that combines this kind of hardness representation with the language model in some sense. But also what we are probably missing now and we need to get into, and there are some companies that are starting to think about this, is most of real science is from your laptop. Wet lab experiments, robotics is an example. There is stuff that it's not only in the laptop itself. So I think the path is gonna be to go through a more environment-involved agent that can operate bigger systems that can do experiment that maybe take weeks or days. I don't know.
And do you mean just computational experiments or actual real world?
I think it's real world stuff because that is eventually what we want, right? I don't know if this is possible in 3 years, but that is what we want. We want agents to be able to find new drugs to cure cancer. Science. The goal of science is solving problems, big problems that humanity has. So eventually, we want to use language models to solve those kind of problems.
So it sounds like don't bet against scale, but also the path to an AI scientist is probably just the capability of longer time horizons with an actual empirical loop.
Yeah. Every time my bet was against scale, that was basically a wrong bet. So
Yeah.
I betted against scale multiple times in the course of my research life.
Yeah.
And eventually scale won. Now, I don't want to make this like into like the inductive fallacy of always thinking that like scale is gonna always win, but it feels like this is becoming too frequent. Like I failed too many times betting against scale.
Yeah. Chenhao?
Yeah, I guess like I think maybe I don't know. I guess like there's some discussion in the comment about what AI scientist is.
Yeah.
I do think like we are kind of in the session of like CAIS, which is like I guess by definition we accepted a bunch of papers that are already done by AI scientists. And personally, I also have a website like Agent for Science Dog that I just shared. I think in general, like if the scope is that like it can produce some kind of plausible looking, maybe like not only plausible, actually like valid experiments.
But today
Like,
it's
it
really
can
a tool.
come up with a hypothesis, run experiment, validate that, falsify or prove that hypothesis. I think we already have that kind of AI scientist, but maybe like we are talking about a much more ambitious type of AI scientist that can solve like bigger breakthroughs. And if we take that, I think like what the two options that we talk about, one is framework and one is model. I agree that we need a mix of both, and I think scaling might still have a way, but I think at the same time, I think learning on the task, like I think a lot of like what a great scientist does is not like a generalist kind of approach. Is like while working on problem, develop a lot of insights and drilling in them. And I do think both model size or like model and framework can help that drilling process. Like some of this might be maintaining a better memory, maintaining a better kind of context of what to think about and so on. At the same time, I do think like for the like real big breakthroughs, I do think like there are things that need to happen. I think Feed maybe touched on that, like infrastructure, right? Like we need to have actually labs that can do things, or like even in computer bounded things, right? Like I think part of the reason why in academia we are so resource poor is that like I cannot really run 100 H100s at will, and that is very different from frontier labs, and that kind of limits what kind of thing I can do. And I think having like infrastructure that can enable this kind of things that can be very useful, and wet lab experiment is the obvious one. I think like having more robots that can do things that enables like cycles with frameworks and models, it will be very useful for these things to actually learn things. And finally, incentive. And I do think that are related. Like I guess like is important to think about like what the incentive structure is like for AI scientists. Like I think like there is a lot of like different mechanisms at play in terms of like how the current incentive works. And like if we are being completely honest, maybe like even the current entire incentive around the human scientists is not really motivated to pursue big breakthroughs by design either. So like if we are thinking about big breakthroughs, like we do not really have the current incentives for that. And I think navigating the role of AI scientists is even more complicated. And like, and I think we don't really have the answer to that.
Do you guys think that we can have something that everyone, even skeptics, would agree is a functional AI scientist in the domain of computer science and mathematics and theoretical physics, things that don't require a robotic laboratory, before we actually can make real progress on physical empirical experiments? Just to give you what I think will be a contrarian view, I think that we overestimate science. I think that most of what we call scientific output today is just very easy to do. It really doesn't require that much creativity. I mean, just think of the countless grad students whose advisors say, look, just replicate that paper and take it a step further. Most of science is getting done that way. No one reads it. It's like hazing. It's like if you want to be a member of the club and be a scientist, you have to do this stupid thing that everyone knows is not really worth your time. And then like, what do? We celebrate the 1/10 of 1% of scientists who actually do something truly creative that changes your mind about how the world works. And so when you talk about incentives, how do we make incentives that actually shift that balance so that we go back to a probably not real golden age that we all imagine, sometimes called the gentleman scientist era, where everything was truly curiosity driven. I think that's unrealistic. I think, humans have been humans the whole time with, nasty incentives and backstabbing each other, and it's not all beautiful. But you have to agree, the reality today is the vast majority of scientific work is almost pointless. We're doing it as a ritual. And so if you can throw tokens at that and have that ritualistic science, get done by a machine that doesn't care about earning a PhD, it doesn't care about getting the 3rd paper at some conference so that you have a shot at getting some job. If you could just remove all that nonsense and just have a scientific engine just humming along, trying to make progress, real progress, like postdocs. What kind of scientist? What's a real scientist? A postdoc, the most miserable human in the world. Like, in terms of the ratio between skills and salary, there's no one like a postdoc. It's like hell. You're at the top of your game, and you have like the worst job prospects, and you have to take care of all these undergrads and grad students who can't do anything. How do we make an AI postdoc?
Yeah, good question. I think going back to something you mentioned, how to make everyone agree on AI actually making science. I think it's a matter of definitions. Like, if we agree on definition, we can do that. Otherwise, it's very hard. Like, every time some AI solves a math problem, the main argument against this is like, yeah, it's because no human wanted to actually solve that problem. So it's very hard for us to prove that it's AI scientists work, because there's always this problem in finding the right vocabulary to describe AI science and have people somehow agree on the actual. So this is kind of an open problem that I think it's going to be, until we actually define things, it's going to be very hard to solve. And
it's funny how AI science just becomes the cultural problem of science very quickly.
Yeah, there is this kind of problem right now. We are left with systems that are 100 years, maybe not 100 years, 50 years old, but even peer review is a recent invention somehow.
Yeah.
So we need to adapt to a new system. Even publishing papers by itself is more, like you said, for actually getting a job than for science itself. The paper does not make the science; the paper makes the scientist, because you need a paper to actually get a job. But the paper itself has no as a value, as an artifact, doesn't as much. In fact, most papers can be summarized in a few very important words or statements that people can keep and bring on.
The abstract is too long. It should be 1 sentence.
Yeah, but we are now in this kind of you cannot submit a paper with an abstract that is 1 sentence, right? Because
no,
there is
but you could.
there is this societal norm that basically push people to behave related. I think related work, for example, are an artifact of a past wording, which was very hard to basically recover papers. So we need to have related work, and if you don't cite the actual reviewer's paper, the paper is going to be rejected because of reasons. But the entire paper itself is an artifact of a past word that we're going to try to move forward.
Anything to add, Chenhao?
No, I think this is I think I started the incentive discussion. I think is very, maybe the one thing I want to add, I do think one very useful thing to think about. I think I don't know, personally, I have always not really appreciated the human-like kind of way of thinking about this. I do think an important characteristic of AI scientists and human scientists is that they are different, right? For the exercise that you mentioned, replicating a paper and try to push it forward a little bit, I think that's actually useful for training human scientists who
agreed, but I
never
think
did any research.
I think AI should do it, and AI should read it, and just let us know if there's something truly interesting that comes out of it.
Yeah. I think, but for AI scientists, I think maybe AI, if it's really marginal cost, AI can still do it. But I don't think doing a lot of the exercise that AI has already known how to do is the best way to move AI scientists forward.
Yeah.
And I think thinking about going back to the question of how to build a great AI scientist, I think is a little different. And I think they are just different facets of this problem of thinking about what AI science means that I think we have already covered like many different perspectives, and I think it's useful. Like although we call it AI scientists, I think it's useful to know like it's different from human scientists, and we don't have to like always compare to like what a human scientist does, and we can easily make a clone of that. For instance, like that's a big difference. Like and we cannot really do that for any human scientist. And I think like hopefully I do hope like the fact that the recent like big advances in this area, or like we are talking more about AI scientists, I think hopefully can kind of remove this narrative or this, I guess, almost like obsession around like human-like things. And I think AI science is fundamentally different from humans, and that's why we should have like different structures around it.
Well, maybe we should just think of it as a tool. That's it. It's just a tool. So
what I think is one point I think is important here is that like science also, like it's very hard to predict what's gonna be useful in the future. If you think about like neural networks, they've been like there for a while, but like it isn't after we got like very fast GPUs that those actually started to bring contributions. So it's very hard even to predict what's gonna be useful, and incremental work made by humans, even if it's like take a paper and add one step, is often useful. I think like science works well with high temperature. You need some noise in the system that eventually settle itself over time, and you can actually find a good thing. So I think like these must be considered when we build AI scientists, because I think AI scientists might work very well in very narrow domains, but high temperature science, which is actually what is useful, it might be harder to replicate.
Well, folks, we're in the final mile of this session, and I wanted to make sure you, the audience, have a chance to ask some questions or share some ideas. Drew, what do you think? How should we do this? We can use the chat and bring people to the stage. We can just open it up. We only have 42 people. It might not be too chaotic. What's your instinct?
I think we have a few questions in the chat, which we could perhaps just read off and take first, and then perhaps open the floor up for folks who might want to ask live. Is that okay? Yeah.
Sounds good. So everyone, ask your questions, and we're going to start crawling through them.
Yeah.
Okay.
There's one really interesting one early on from this guy called Rajesh. I could read out, which would be to take, which is essentially like, hey, if we're talking about science becoming more like the rest of the economy, right? Or if you're thinking of science as a resource allocation problem now, because agents can do a certain kind of science very fast. Do you all find yourself as scientists thinking a little bit more like economists with your resources, whether it's like sort of talent, whether it's compute, whether it's managing agents, and are we going to see more of economic thinking in the scientist workflow? It's a fascinating question.
Good question.
Person who asked that question first. I didn't mean it as in, will the rich get richer or the poor, right? I mean, like, economics is a science that came up to address resource allocation in an economy that is not an agrarian economy, right? But an industrial economy where people are creating complex products that are commoditized. So to the extent that knowledge is getting commoditized as a result of AI, do we need to bring both economics, like the kind of neoclassical economics that people started doing in the mid-19th century, to the study of science? So it's like, is meta science going to look more like economics? And are we going to build those ideas into the design of whatever AI
What do you
research?
mean concretely? What would that look like? What could that look like?
I mean, if I might add an example, John, for example, what the Paradigma folks are building, right? Like a research infrastructure where there's insane coordination, which can be tied back down to economic principles. So perhaps that would be like an example of, like, to build an infrastructure piece like that, you'd require more of sort of an economic understanding than the science piece, right? On how agents communicate.
I mean, it sounds like when you say economics, you mean just good systems theory.
Yeah, sure. Yeah, like.
Okay. I think that it's going to be more than just plain systems theory, right? So suppose, I mean, think about how, if you're running a corporation, how do you decide to allocate the budget of your corporation? Who do you hire? Who do you fire? What divisions do you put more money into? So all of those could be the kind of decisions that you make for AI agents, right? That, well, here are some hypotheses. Well, how do you decide which? So,
it's funny. Your idea kind of hints at something that I've noticed myself, which is what we call AI used to be math, and literally machine learning was just a branch of statistics. And then we basically moved into something closer to biology as soon as we had the large language model, even just the language model, because suddenly we didn't have a theory to explain its capabilities. And so you had to test it empirically. And there was a whole cottage industry, you may remember, of papers where they would create probes, where you would look at neurons and try and figure out what it's thinking. That's biology. Are we moving now into social science, where the locus of the mystery is not the individual model, it's the society of agents, where you have dynamics that are as complex as the sort of phenomena that social science focuses on?
So Marvin Minsky has a book called The Society of Mind, which very much has that quality to it.
It does. It certainly has that vibe. It feels like we're moving towards social science.
I just want to add, like, I do think like it has, like, I'm not sure whether it is more. I think it has always been there, and I think like this maybe like this is what John was originally. I think maybe like more visible. I wanted to like all PIs have been applying for fundings. NSF, NIH have always been in charge of allocating fundings. I think like no science. Maybe that's too, like, at least in the past 50 years or so, I think like science is expensive and is not like something that you just can do with a pen. But maybe like in math that's still true to some extent. But like math is also the one that's kind of going through the biggest changes right now in many ways. I think like maybe like part of this is that now hopefully I think it's good that this becomes more visible, and I think like using John's analogy, I think like the entire thing will be much richer than just this part, right? I think like we will still have like more biology still study, which I think personally I also work on interpretability. I think that's still important, and it's not like probing experiments are no longer being done right now. And I think it's good that we are kind of bringing these conversations together, and I think it's a very big problem. Is like, many ways a very exciting time to be in. I think going back to the analogy of like agriculture evolution sped up 1,000 years, I think is probably even bigger than that revolution. And it will happen much faster, and is very exciting in that sense.
Yeah. I think like the economics of this should consider how do we allocate resources, like someone has said in the chat, for maybe less evident questions that might bring value that we don't know in the future. A lot of science is made from people that have been given money to do something that we didn't think was important back then, but now it's very important now. This is like something that is very hard to allocate resources for, because like it's not valuable at T0, but it's going to be valuable at T100 when something comes that like changes the way of the world. So it's very hard, I think, like to think about an economics of this that is efficient and cover this expected result.
Drew, it's funny you should mention prediction markets for science. That's something that I actually proposed to Science, the journal, back in 2010. I actually like met with a bunch of people at Science, with the editors, and I was like, a friend of mine who is now my co-founder, and they were like, that can't work, because as soon as you have people betting on science, it corrupts all of science. And you look at today at the prediction market situation, and you're like, yeah, they're probably right.
Yeah, that's right. I've seen some work on like sort of models predicting experimental outcomes, right? So maybe forecasts for scientific outcome, perhaps prediction markets was like
different.
Like maybe forecasting. John, since we're almost on time, I do think we have one question which I'd like to address. It's from Aditya, right? And it sort of flows very naturally from this conversation, which is that, hey, if it's seeing this work of science change so much in different ways, as an undergraduate researcher who's still learning how to do research, right? Where do I sort of draw a fine line in terms of when to use AI, both because I don't want to, sort of compromise learning my skills just to improve my productivity. So of course, all are super seniors. We are already like PIs allocating resources, thinking at a high level. But if you were an undergrad right now, how would you sort of respond to this? Where to use AI and where not?
I would be so stressed.
Oh my God.
Oh my God. Imagine you're an undergraduate farmer during the agricultural revolution, and there's all these companies that are selling you these new metal tools, and you still have to like feed, the village. Like you still have this job. You have to do this job, which is like learning and producing. And like you have no idea what is going to be relevant on the timescale of not just your lifetime, but like next 2 years. Like so stressful. I mean, the really like trite advice is use AI like crazy. Like use it, become an expert. You just absolutely have to learn this horse stuff and this plow stuff. Like you've got to do that. But that's trite advice. Like everyone already knows that. That's, like I don't know how to go deeper than that advice. I would freak out if I was an undergraduate researcher right now.
Yeah, I think the like meta ability of like learning and adapt is important, and I think it has always been important. And I think AI again kind of highlight that, and I think like I don't know, I'm not sure about education in other countries, but I think when I was a kid, I think there was like always this illusion that like once you finish high school or like once you finish college, then you are done. But like that has never been the life. Like I think for anyone who actually kind of lives in the world, kind of learning is just a lifelong activity, and I think that is no different between undergrads and us. Like I try to learn all these AI skills as much as I can, and people more and more senior people now carve out more time like doing work with AI. I think that is kind of
so same advice
in this process.
I think
yeah, go ahead. I just want to add one more thing before I turn over to Fid. I do think it's actually also important to work on skills without AI. I think more and more I try to ask my students to write without AI. I think it's just a different experience, and I don't think like it's useful to figure out like how you can maintain the balance. And I think if you lose the ability to write without AI, I think is actually kind of visible, affecting how you think and so on. That's very important.
Yeah, I think concepts are still very useful. The world is complex, and it's very hard to transfer the entire knowledge of the thing you want to build into a language model, and you still have to know what you want to do. Like even if you're building like an app or something for an experiment, there are like thousands of like databases you could use, but you need to know which is the best one. And like it's not like there's no best one that like covers all the use cases. And you can just ask AI to pick the best one. You need to know what is going to be your use case to actually decide. So I think like learning concepts, high-level concepts is very useful and will allow you to basically, if you know general programming in Python, maybe transferring to a similar language is not impossible. If you know programming in C++, maybe you can easily ask a language model to create Rust code for you, because like there are a few things you need to know, but eventually it's low-level code. So the abstractions are there. So I think like learning the concept is still fundamental and it's very important, and it's going to be very useful for any scientific work you are going to do, because like not everything is very easy to describe to a language model, and building is much more complex. Like the world is much more complex. When you deploy an app to like 1,000 people, the world is not your own laptop. So
yeah. Okay, one more piece of advice for undergraduates. There's this saying here, I'm in Silicon Valley, and there's a famous kind of like, it's like the motto, which is to swim against the stream. When everyone is going one way, then it is almost always valuable to go the other way. It's not easier, but it's valuable. So one piece of advice would be, hey, when you see all of your classmates just using ChatGPT to solve all the problems and become expert users of AI, maybe that's the time to become an old school learner and end up being one of the 1% of 1% of 1% of people in 5 years' time who actually understands a domain. When you're the only guy who understand something, you have a huge advantage. And so maybe the best advice is to do the opposite. Don't ignore AI, but you have to have the discipline to actually learn how to do this. A friend of mine is a professor of quantum physics at Stanford, and he's on sabbatical working with DeepMind to teach Gemini how to do theoretical physics. And I had dinner with him a few days ago, and he said the most striking thing, two things. First, he said, these experiments I'm running are so stupidly expensive and high and large scale. The number of tokens, the amount of compute is just like shocking for even stupid things. And then secondly, he said, I'm not sure there are going to be many humans left like me who went through this. It's almost like becoming a priest. To be able to understand theoretical physics, to be able to be creative, not just understand it, but be creative in the domain of theoretical physics is so hard for humans. It's like becoming a concert pianist or, learning 5 languages. It's like, why would you bother? It's so hard. And he's like, the incentive for doing this is just going to go down and down. He can't see any other future where there are dramatically fewer humans who can do this. And he says that's a danger, because we're making a bet that AI will be so good at doing this science that we can kind of leave it to AI, but we won't even be able to understand if it's hit a limit in its exploration, because we won't even have the skills. We'll just have to take it, we'll have to trust the AI. That is the biggest danger in AI science, is that we just get lazy. You're not doing science, you're doing vibe science. You're just sort of like, saying, you're giving helpful, like a PI who got way too lazy and doesn't do experiments anymore. You're just chasing grants. All you're doing is chasing grants and, pushing money around, pushing tokens. So my advice to you would be, don't be that. Be that remaining human who really, really deeply understands something, and you have to love the game for its own sake, even though it's hard.
That's great. That's great, folks. Thank you. We are at time. If it's okay, should we wrap up this conversation, if that's fine with all of you? This is great. Thank you so much for taking the time. I think it's phenomenal. A conversation's been incredibly useful if it's covered all the possible ground, right? Like from, let's say, how to use AI to maximize your output, to what is the new scientific infrastructure we need for the future, to now, thanks to John, still retaining that essence of human expertise in this world of AI and science, right? So thanks again for taking the time. This was absolutely wonderful. Folks had a great time from the engagement in the chat.